Assalamualaikum warahmatullahi wabarakatuh, and good day everyone. Okay, so our next topic in this chapter, which is our last topic here, okay, we can use Laplace transform to solve a system of differential equation. Okay, so saying about a system, we have learned about a system of linear equation. So remember, we can solve a linear equation, a system of linear equation by using a matrix form, by using a simultaneous equation, and so on. So does this system of differential equation. But before we are going to use that, we have to use Laplace transform first, okay, in order for us to omit the derivative form. Okay, so how can we solve the system of differential equation by using Laplace transform? Right. So for this case, let's take a look. We have here, we have a system when we have more than one differential equation. Okay, just like before, we only need to solve one differential equation. So we apply the Laplace transform, we apply the condition given, and then we can just solve it. So now when we have to deal with more than one differential equation, it forms a system. So this is one system of differential equation where we have two differential equation, we have two conditions. So we are going to use Laplace transform here to solve this kind of problem. So Laplace transform Laplace transform are useful in analyzing systems of differential equation. So in this course, we will limit our discussion only to 2x2 system. So let's take a look at this example. Okay, so we have dx dt equals to 2x plus y, where the given condition is x not equals to 1. Okay, another one is dy dt equals to 3x plus 4y, where the condition of y not equals to 0. So we have more than one differential equation. Differential equation 1, differential equation 2. So we can solve this by applying the Laplace transform to both sides of each equation. Okay, so for this equation, it is x prime. So we transform x prime, we transform to x, we transform y. And then this one, we transform y prime, we transform 3x, we transform 4y. Okay, so what we will have transforming x prime, we should have what? Sxs minus x naught equals to 2xs plus ys. Okay, and then this one, sys minus y naught equals to 3xs plus with 4ys. So as you can see, this is the condition. So we just substitute the condition given. That's why here is 1 and here is 0. So now this can be written as this. Okay, from A here, now we can write this as in B here. So we just apply the condition. Okay, so we have here, then we need to rearrange. Okay, so how can we rearrange? By putting xs and ys to the left hand side and the rest to the right hand side. So here, as you can see, here we have xs. Here we have xs. Right? Here we have ys, xs, and ys. So put xs and ys to the left hand side and then rearrange and simplify to get this. So let's do it. Okay. Okay. Now, once you have applied the condition, so we have sxs minus 1, okay, equals to 2xs plus ys. So we just put sxs minus 2xs minus ys equals to 1. Okay, and then sys minus 3xs minus 4ys equals to 0. So we put xs and ys, all of xs and ys to the left hand side here. Okay, so we can factorize s minus 2. So s minus 2 here. Minus ys equals to 1. And then this one, minus 3xs. S minus 4, S minus 4ys. So we have to rearrange this in terms of xs and ys. So now we have in terms of system, okay, S minus 2 minus 3 xs xs minus ys plus S minus 4. Okay, this one minus minus ys, this one s minus 4 ys equals to 1 equals to 0. So as you can see, we have arranged it in terms of a system of xs and ys, which has solution of this. So how can we find this? So we can find this by solving the system of this differential equation simultaneously, all right? Where if we can write, okay, how can we find the solution of this? Okay, if we can convert this to a metric system, we can have what? We can have s minus 2. This one is 1. This one is minus 3. This one is s minus 4. xs, ys equals to 1, 0. So we are going to solve this system to find the value of xs and ys. So the easiest way is to use Kramer's rule. Okay. So once you got xs and ys, okay, once you got xs and ys, okay, so in order to find this xs and ys, we can use Kramer's rule. Usually it is easy for you to sort this system to a metric system, and then you can solve it by using Kramer's. Okay, because it involves such variables, all right? So by using Kramer's rule, it will ease the process. Okay, so once you obtain the answer for xs and ys, once you obtain the function of xs and ys, remember, we want to solve this system where this system is in terms of the x dt and dy dt. So we need to have our answer in terms of xt and yt. So these xs and ys need to be simplified first by using partial fraction. All right, and then we can get this xt and yt by inverse transform of xs and inverse transform of ys. So theoretically, this is the steps of solving a system of differential equation. Okay, let's try to do example for this. Okay, so let's take a look at the note. In this example, reducing the system to xs and ys terms is just a process of algebraic manipulations. However, in certain case, it may get messy because it involves lots of variables. We have s, we have xs, we have ys, right? So let's try to simplify this calculation by using Kramer's rule. Okay, let's try the example here. Okay, so in example 25, we do it one by one here. Okay, so your first step is to transform this system to Laplace transform by transforming every expression here. So this is x prime, so we transform x prime, we transform negative x there, put negative outside, and we transform negative 3y. Okay, so here also y prime, negative x, plus transforming of y. So we will have s x s minus x naught, okay, and then equals to negative xs minus 3ys. And then this one, sys minus y naught equals to negative xs plus ys. So here apply the condition, all right, apply the condition where x naught equals to 0 and y naught equals to 1. So here we have sxs, so this is 0 equals to negative xs minus 3ys, and this one is 1, so sys minus 1 equals to minus xs plus ys. So we want to rearrange by putting xs and ys to the left hand side, and the rest should be in the right hand side. Okay, so here we have as xs, sorry, as xs plus xs plus 3ys equals to 0. Okay, and then this is x, this is x, so s plus 1 xs plus 3ys equals to 0. So this is your first equation. Okay, and then look at this one. We have xs. Okay, we put this to the left hand side. And then we have sys minus ys equals to 1. So here we have xs factorize s minus 1, ys equals to 1. So this is your second equation. Okay, by looking at this, we rewrite it again so that we can see it clear. So as you can see, we have sort this in terms of a matrix arrangement. Okay, it is easy for you to convert this to a matrix system. So we have here, this one is sorry, this is s plus 1. This one, yes. So s plus 1, s plus 1. This one is 3. This one is 1. This one is s minus 1. Okay. And then xs, ys equals to 0 and 1. So we want to find x and y by using Kramer's, remember? So we have, let's say here, we have a matrix of A equals to s plus 1, 3, 1, s minus 1, okay? And remember, by Kramer's, we want to have xs, so xs is A1 divided by a determinant of A1 divided by determinant A. Okay, so what is determinant A? Determinant A1. Okay, and then by Kramer's rule again, ys is given by determinant of A2 divided by determinant A. So we have A, okay, and then we have A1 by substituting 0, 1 here to the first column, all right? 0, 1, 3 s minus 1, and we have A2 by substituting 0, 1 to the second column, okay, here we have s plus 1, 1, 0, and 1. So in order to get xs and ys here, so we just have to find the determinant of A1. Determinant, how can you find determinant? Divide by determinant of A. Okay, which give you 0 minus 3, so minus 3. This one s plus 1, s minus 1, minus 3. So s plus 1, s minus 1, minus 3. So this is xs. Later we simplify. And then for ys, it is determinant of A2 divided by determinant of A. Okay, and then we can have here s plus 1 minus 0, so s plus 1 divided by s plus 1, s minus 1, minus 3. Okay, so simplify. Here we have xs equals to minus 3. Expand this, we have s squared minus 4, right? And then ys equals to s plus 1. Expand minus 3, we can have x squared minus 4. So in order to get xt, we have to inverse transform of xs. Same with yt. We have to inverse transform of ys. Alright, so let's take a look at this. So here we have s squared minus 4 should be s squared minus 2 squared. Then this one become 2, but we want to remain negative 3. So we have to multiply with negative 3 there, which is negative 3 over 2. We put it outside. And then we inverse 2 over s squared minus 2 squared. So by table of transformation, it is shine 2t. Okay. And then for yt, same process. We inverse transform of s over s squared minus 4 is 2 squared plus, okay, we just put it one by one fraction here. Inverse of 1 s squared minus 4 minus 2 squared. And this one should be 2, but here we have 1. So just multiply with 1 over 2. Okay, then we have here s. Then this is cos 2t. And then this is 1 over 2 sine 2t. So this is the solution for yt and xt. All right. So this is how you solve the differential system of differential equation. Okay, so it is easy for you to apply the Kramer's rule, all right, to sort the variables and then with s and xs and ys there. So this is how you solve the system, okay? All right, so I hope you can try the rest of the example. If you have problem, you can contact me. All right, thank you guys. Assalamualaikum.